So yeah, my topic is optimizing tunnels modeling through visual programming. Dynamo was chosen as the main application. Sorry for this pop-up windows.
Don't worry.
Okay. So the study was made. It was based on the tunnel. Tunnel, unlike residential buildings, they have high scale. They have high scale range, starting from details. For example, the thickness of the isolation can be a few millimeters, and the length of the whole structure can be up to hundreds of kilometers. So it gives some differences and small issues. Also, it has some uncertain design, which means that before we made all the groundwork, we don't know exactly what circumstances we'll have in terms of soil and ground conditions. We can only assume, depending on some shafts we make as a first step before construction, but then approximation is used. And for this reason, at some parts, the design can be defined with some amount of proximity. Like, for example, we are sure we can use such type of structure with proximity of 60%. And for this reason, variant investigation could be very useful and application beam to do this case. That's why such topic was chosen. So main objectives were to connect two worlds, to find optimal way of modeling of the main part for the variant investigation, and improve the process of variant exploration. One of the challenge, personally for me, was to get smooth joints for curved path. It's a geometrical nuance of tunneling. First question was, what is the optimal way to model units? Since Dynamo was proposed as a main, for me it was choice between two ways: to make direct solid shapes with Dynamo, or to create parametric model first, and then afterwards use Dynamo simply to place them within the path. So I made small comparison, and my personal conclusion was that it was better for the future usage of model in 4D or 5D. It's better to use parametric models, families, and place them with Dynamo. So use Dynamo as a supportive tool, but not as a main one. Two main approaches of disposition of such units could be by coordinates from Excel sheet or by CAD polyline. In first case, it's easier to change values, high interpretability. In second case, we have low precision loss risks because we got the exact path without any roundings in terms of figures. And we can also faster see changes if we connect it as a link. First step was unit prototyping. First variant was structural framing. It had some native geometry controls, which were very useful. It was easy to model by lines, but shape handles comprise the behavior of the family. Maybe it could be fixed, but in any case, it made the work more difficult, and it was easier to collapse the family. For this reason, I switched to adaptive components. On the right, you can see the first version. The feature of included cuttings in order to get joints when the path is curved were applied. Also, the expansion feature, which was necessary to get the geometry. But at first, transition region wasn't modeled, so it has to be more smooth in reality. For this reason, second version of adaptive model was created, obtaining the same features as well as smooth connections, which gave more precise geometry and thus more precise volume for the KTO in the future. Next step, once the families were liberated, it was to displace them according to the path. The workflow, simple version of workflow you can see on the left on the top. So we have some Excel sheet, we have family, we use Dynamo to place by coordinates. once the families are placed, for example, if the path is curved, we need to adjust these joints by adding some cutting angles. So basically each angle was just halved. So if the angle is 8.33, so we give 4.16 to one element and 4.16 to another, so that we spread this discrepancy between two subsequential units. Another workflow was with a polyline obtained from the link from Civil 3D. The second part was the same, was more about math and getting angles. The first part was a little bit changed. Instead of Excel, CAD-Link was used. And in order to map, to show to Revit which family, which type, where to place, it was decided to use such way. So the path was deconstructed into few lines, and each line was assigned with a layer, and the layer name corresponded to the name of the type inside the family, so that the lines could be, the layers could be mapped with the type of family which has to be used. Regarding the limitations and joint issue, even though the families could have inclined joints, these formulas in geometry, they didn't work really well in case the tunnel was bending in both planes, not only in horizontal or vertical, but in both. But taking into account that radii of the elements are usually high, it would be hard to consider. It would have low influence on QTO. Even here, when the bendings are visible, so they kind of exaggerated. Even in this case, the intersection was 2-3 millimeters. But in the future, it has to be considered during the interference checks, for example, in order not to get false positive results. The limitation is regarding the angles, but since tunnels has usually high radii, the angle is usually lower than 5, even less. The next study was based on the excavation supports, which basically consisted of steel frame connected with some steel connections, which here are not presented. So the first step was to create the basic family with a frame, which also has to have feature of expansion. It was tested if it is possible to make it also prone to be scheduled, and it was reached through the connection in nested families. And the next step was to use Dynamo to place these connection elements. So I think this approach was a good choice. So in order to do some simple shapes, it's well to use families, and in order to place detailings, Dynamo can help a lot to do it faster, so you don't do it manually, and especially if it's hard to put everything inside one family. The last study was based on the excavations. Grouting basically is the way of reinforcing the soil. So you can imagine it as piles which are inserted in front of your current tunnel. When you dig deeper, before you make new advancement, before you get new segment, you place in front of you injections with cement, which after that becomes kind of, they form a shield of piles. In order to get the optimal geometry, so we need to have minimal overlap in the end. And since they expand, if we change angle or we change radii or we change the step, it's not that easy to do it manually, but Dynamo can help. And Unit Design was used as a tool to find this solution faster through placing some limitations and expected results in terms of constraints. And of course, in the future, once we get ready for the pile, for the injection, they could be modeled here at this point as a direct shape. That's for the visualization. So in order to sum up, I would like to say that visual programs such as Dynamo can speed up process, can be used for data stats as detailing, can be used with general design, find an optimal engineering solution, but it has some limited capabilities as a standalone tool. For example, it's better if we have some parametric models elaborated, and solutions made with nodes are not scalable, unlike those which are written entirely in the code. Thank you for the attention.